channel Safa's Center for Learning. In this session, we are going to discuss about the geography, part which is there for the Appsc Group 2. So if you see the syllabus is mainly devised in terms of the 4 parts: physical geography, next human geography, and economic geography, 3 parts. Today we are going to dive into the part of physical geography. In that we are going to discuss about the interior of the earth. Okay, without wasting the time, let's move on to the subject. So before discussing interior of the earth, I want to tell you about this content. Mainly I took it from the NCERT, because NCERTs are the base for the Appsc or the UPSC, any competitive exam which is held in the India. So this mainly syllabus I took it from the NCERTs. Okay, let's dive into the sources. So when we talk about the interior of earth, okay, so what is there in the earth? That is a question came from our mind. So in order to answer that question, we need some sources. That sources we differentiate into direct sources, indirect sources. Direct sources are the sources which we can see directly, that these are the sources which tells about the results of few experiments. And indirect sources are the indirect sources of different matters. Okay, let's discuss one by one. Direct sources. What are the direct sources? So when we do mining, there are lot of material coming from the inside of the earth's surface, and we can find lot of different types of earth materials. That's how we found the 108 elements also. So just by digging the earth's surface, we can find out what are there in the inside of the earth. Okay, and projects to penetrate deeper depths. This is the one more important thing. So if you see that we are conducting the experiment called Samudrayan, so which is very much helpful to analysis the inside of the earth and at the same time inside the ocean. So these are the things. Okay, deeper depths and integrated ocean drilling projects. Like these volcanic eruptions. Why volcanic eruptions is very much important? Because when volcano is erupted, lot of material coming from the inside of the earth's surface. This material tells about the what is there in the inside of the earth and what behavior it shows and how much it is helpful for the human beings. Every information it tells that. Okay, now let's talk about the indirect sources. Indirect sources, firstly, it provides the information about the interior, such as the temperature and the pressure increase when we go down. Okay, when we go interior of the earth, what is the temperature changing, what is the pressure changing, all this information is coming from the properties of matter. That is, like these are indirect sources. First one, meteors. Meteors are the they are like fragments of the rock surface. Fragments of the rock surface. Okay, that's similar to the structure of the earth. When we study the meteor, we can easily observe that like what makes up the earth surface or earth interior. So in order to make a resemblance, we'll study meteors. Okay, so in order to form a resemblance, in order to make a resemblance, also we study the meteors for the earth interior purpose. And the gravitational force G. G is not same at all the altitudes. It is different at different altitudes. If you say that poles, and near the poles it is very high, around 10. Near the equator it is very less, it is 9.8. Even though there is no much difference, but it makes a lot of difference when we compare 9.8 and 10, the gravity. Okay, these gravitational things, or these gravity at different points also influence many factors, such as what are the materials such as located over there. Okay, materials location also, it is very important. So the reading of the gravity at different places influenced by many factors, such as mass of the material or uneven distribution of the mass of the material, etc. Suppose we are able to find out iron, copper, all these material with the help of gravity difference, we can also find it. So the difference between the gravity between one place to another place is also called gravity anomaly. Okay, and the magnetic surface. So magnetic surface also provides the distribution of the magnetic materials inside the Earth's surface. Seismic activity. Seismic activity means like earthquakes. Okay, earthquakes also provides the what are the layers, how the total Earth is formed in a layered manner. It provides the information about the earthquake. Earth. The seismic activity, or we can also call it as earthquakes, provides a complete picture of the layered interior. What is there inside of the Earth, how the Earth is formed, layered by layer, all this information coming from the earthquakes. Let us discuss about the earthquakes a bit. So what is earthquake? Earthquake is nothing but shaking of the earth. Earthquake is what? Shaking of the earth. So basically, why earthquakes happen and where the earthquakes mostly happen? Earthquakes mostly happens where the oceans and earth crust meets. Let us take Japan, Malaysia, Philippines. These are like island structures. Not island exactly, these are the structures which 3/4 of land is covered with the water. That means when there is a water and the land, there is we can experience a earthquake in that part. Okay, so earthquakes are the natural events basically, and it is caused due to the release of energy. Why? It is caused due to the release of energy which generates waves that travels in all directions. I'll show you one diagram about the earthquakes. Let's see the anatomy of earthquake. So this is the two plate boundaries. There are three types of plate boundaries. We know that. That is one plate boundary is a convergent boundary where the two plates moving each other, the continents we can call it as. Another one is divergent plate boundary where the two plates are moving away from each other. There forms a crust, or there forms a different types of jaws or many more. And another form of plate boundary is transverse boundary. That means one upon another. It will slide one upon another. Because of this plate boundary tectonics, there is a happening of earthquake. What? Earthquake. So if you observe this line is called fault line. What is it called? Fault line. Fault line is the line at which you can observe the movements of the earth. Okay. Along these fault lines, the fractures happen and the crackings are happening. That's why it's called the fault line. So below that fault line, if you see that, this is called hypocenter or the focus. This line. This is where the earthquake rupture starts. Okay, this is called focus point. And just above the focus point on the earth's surface, there is an epicenter. So this is the point at which the surface of the earth directly experiences the earthquake. This is the first point where earthquake is experienced by the earth. Okay, and these are the two plates, and these red color lines are called the seismic waves. Okay, so these seismic waves also differentiate into two types. One is the body waves, another one is surface waves. Body waves further disintegrated into P waves, we also call the primary waves, and secondary waves. Why it is called primary? Because it appears in the first. Why secondary? It appears in the second with some lag. That's why it's called like that. So seismic waves are also two types. Okay, let's pass into this one. So the release of energy occurs along a fault line with sharp break in the crustal rocks. As I explained in the just few minutes back. So because of the energy releasing at the fault line or the focus point, so we can there is an experience of there is a formation of earthquake. Okay, so rocks along fault line tend to move in opposite directions. So move in opposite directions, and overlaying the rocks strata press them, nothing but just moving past one over each other, and thereby whatever the mud or whatever the structure in between them is ruptured, and the eventually earthquake happened. The friction locks them together. So this point is very much that their tendency to move apart at some point of the time to overcome the friction. That means one point of time, whatever the friction that locked these two tectonic plates, it is eroded. At that point, the blocks get deformed and there is a formation of sliding of one another individually. Okay, that releases the energy in the form of waves. Okay, that releases the energy in the form of waves. Yeah. So I discussed about the focus of an earthquake, and epicenter is just nothing but the point on the surface nearest to the focus, just above the focus. Next, earthquakes waves. As I discussed, there are two types of waves are there. One is the body waves and the surface waves. Again, the body waves are subdivided into P waves and the S waves. P waves moves very faster and the first to arrive at the surface. So that's why these are called primary waves, just like a sound waves. So when you see that the graph, seismograph, it will shows like this. Some lag. After that, some lag and amplitude like this. These waves, we call it as primary waves because it appears as the first one. These waves are called secondary waves, and these waves with some amplitude is called surface waves. Okay, so P waves, very, very, very important. They are like a sound waves. P waves are like sound waves. Just remember opposite of S. Here the S waves different. The P waves just opposite is sound waves. PS. Okay. They travel through the gaseous, liquid and solid material. That's why it appears on the Earth's surface at the first. Okay. But when compared to the S waves only travels to the solid materials. So these S waves are the helpful for the scientists to understand the structure of the interior. Okay. These S waves are very important. So P waves travel through all three types of materials, arrive at the further surface, but the S waves only travel at the solid materials. Now surface waves. Surface waves are the waves which interacts with the surface rocks or the surface of the earth. Okay. They move along the surface and they are the destructive in nature. They are the one which destructs the matter on the surface or the material or the buildings, whatever. So they cause the displacement of the rocks, hence the collapse of the structure of us. And they last to report on seismograph. As I said that they are the last to report on the seismograph with some amplitude. They are more destructive in nature. Okay, so let's discuss the propagation of earthquakes. So there are different types of propagation of earthquakes. P waves vibrates parallel to the direction of the wave, whereas the S waves perpendicular to the wave of direction. It is very important. S waves perpendicular to the direction, and P waves just like a sound waves parallel to the directions. Okay, that is the propagation of earthquakes. So the S waves forms a truss and crest as it is go like this, whereas the P waves travels like this, just like a sound waves. Whereas it forms a crust and truss. Thank you for